All right. So number 6 was one that Desmos wasn't friendly with. Agree? Oh, I said odds. Okay, which one had
13?
13. All right, let's take a look at number 13. Okay, so there might be the opportunity that Desmos gets silly because it doesn't recognize multiple variables being different letters. So I have this. Okay, so imagine when you plugged it into Desmos, did anything even show up?
If you put it equal to y, then there was like a line across the x-axis and then some other wiggly things. If you put it equal to a different variable, there is
nothing. Okay. So Desmos isn't going to be our buddy here. Okay. So if we come across this situation, which you might, let's think of it in a little bit different way. Let's see. I'm just going to break 24 down into its prime components. So I know 24 is 2 times 12. And then I know that's 2 times 6. And then I know that's 2 times 3. So if I were to go 2 times 2 times 2 times 3, I would get 24. Do you feel comfortable with what I've just done? Okay, so I'm going to list that. So I have 2 times 2 times 2 times 3. X to the 4th is the same thing as, and I'm kind of going on a real basic level, but basically, if I rewrote that in its most broken down form, I would get to that point. Are you following what I'm doing so far? Now, this is where Desmos or a calculator would help you. Like if you wanted to break down a number and you're not real dominant with, breaking down a number, just go 24 divided by 2. Oh, okay, it was an even number. Cool, keep going. Go until it's not an even number, then try 3. And then if 3 doesn't work, then try 5. Try the prime numbers. Okay, so now I want to look at this. So I'm going to do the same thing with 30. 30 breaks down as 2 and 15. Is that okay? 15 is not going to break down with 2. What does 15 break down with? 3 and 5. So now I know that 30 is 2, 3, and 5 multiplied together. So I have 2 times 3 times 5. X squared breaks down to XX. Y squared breaks down to YY. Okay? And I know this is a real simplistic approach, but let's face it, there's times that we can revert back to like middle school math or maybe even elementary school math to do well. Hey, Ish is trying to decide if he wants to join us or not. But I went really back to the basics. And I know that a lot of times there's other math classes you might have taken in high school where it's like you might have some of the basics, but you kind of forget about it because it's like, oh, dude, you recognize that this happens. That's great, but a lot of times what I have found in my career, it doesn't matter what class it is. Sometimes it's nice to realize that the basics are going to work. So is there anything about the blue or the red that I've done so far that you're not sure about what I've done? Okay. All right, so I'm going to just use my highlighter. So I have a 2 and I have a 2. Okay, is there any other 2s that the blues and the reds have in common? No. What's the next number they have in common? 3. So I have a 3 and a 3. What else do they have in common? They have an X and an X. Another X maybe? Do they both have a Y?
Yep.
Okay. And now some of you are going to be like, why'd you highlight the last Y and not the second to the last Y? I don't know. I just didn't. But that's basically what I have in common between my 2 terms. Okay, so I think I can do this. They both have a 2. They both have a 3. 2 times 3 is 6. Like, okay, Stirrup. A little bit harder math. And they both have an XX in common. And X times X is X squared. And they both have a Y in common, so I get a Y. And then I have a set of parentheses, and then we're going to take a look at it. What do I have left in the blue that I haven't highlighted? It's okay if you go basic.
So like 4x squared.
Yeah, 4x squared. I have 22xx, which is 4x squared. What do I have in common, or what do I have left in the red? 5y. Friends, we just factored it. Okay? So Desmos won't be nice for you because it's a multi-variable binomial. Okay? Now, there are, I'm sure, computer algorithms out there that are going to work. But, you know, as far as Desmos, I haven't learned it. Okay? Was there anything else on that front page? Yeah.
Desmos could do, I was just confused how to get it into that factor form on 15.
15. Okay. So let's take a look at number 15. We're going to jump on Desmos real quick. And those of you who are brand new, I would like you to load on your phone Desmos. And it works really nicely for you. All right. So Desmos 15. So in order for 15 to work, I need to make it y equals. Agree?
Yep.
Okay, so y equals 3x squared plus 5x minus 4. And let's bold it a little bit so it looks a little nicer. All right, so I have this value here and this value here. Okay. Is there anything about those decimals? I realize they have them only out to 3 decimal places, but here's the problem. Those are actually going to be irrational points. An irrational point can't be written as a fraction, which then means this can't be factored. Okay, there's a lot of tricks in math that we can try to manipulate stuff with it. One skill is called completing the square, but it's not going to necessarily help you factor it. It doesn't become, by completing the square, it doesn't become a factorable thing. So there are not 2 binomials that I know of, like 2x plus 3 and 3x minus 7 or something like that. There's nothing I can multiply together by foiling that's going to get us to that point. Okay? So Desmos, though it is pretty valuable, there are some shortcomings to it for a reason. Okay? It's not going to recognize an irrational point. It's going to give a 3 decimal approximate of what that point would be. Now, how do you know if it's going to be a rational point or an irrational point just by looking at 3 decimals? And the answer, the mathematical answer is you don't. But just know that the types of things I would give you that would be those kind of points on a test or a quiz, I would give you like 0.33 or 0.333 type of thing, which you need to realize is 1/3. Or I might give you 0.667, so realize that's 2/3. Might give you 0.5, you have to realize that's 1/2. So I probably won't throw at you an irrational or a point like this to say, hey, go ahead and try and figure out the fraction that works, because there isn't. I mean, there are characteristics to an irrational number that, you know, let's face it, there's people out there that, you know, beyond teach math. They sit there and they crunch stuff together. And if I were to find out those exact points, basically what I'd have to do is have to do the quadratic formula or complete the square to figure out what those exact values are. And you're going to come up with, you know, something plus or minus the square root of a number that is not a perfect square. Okay, you're going to wind up with a square root 2 or square root 3 or square root 5 or square root 6, 7, 8, 10. None of those have perfect squares. They're all irrational numbers when you have a square root of it. Okay? But I think that holds okay. Do you feel comfortable with what we've said so far? Nice. Okay. All right. Can we go to the back side of this page? All right. So I'm going to show you a couple of things, but the word up on top is synthetic division. And synthetic division is a tool that was used in order to decipher whether we have rational roots or irrational roots. Okay, now, let me show you how this would have been done without a graphing calculator. So if I take problem number 16, I have this. And I'm going to just show you the background to this. Please do not feel that I am trying to, I'm not trying to blow you out of the water saying this is what you have to know. Okay? So a couple of things took place. The foundation behind this, before the technology existed, you had to use something called this Descartes Rule of Signs. Or Descartes Rule of Signs. Okay, so the very first thing you did is you're like, okay, that's positive. I go positive, negative. So I have a sign change. I have a sign change here, and I have a sign change here. So this means I have 3 or 1 positive rational roots. Okay? You're like, well, how many is it? Is it 3 or 1? I don't know. Okay? Then the next thing that you would do is you would substitute in negative x for wherever you had an x. So if I were to plug a negative x in there, I would get negative x to the 3rd power, which that would come out to negative x times negative x times negative x, which is negative x to the 3rd. I'd plug negative x in there, and that's going to give me negative 5 times negative x quantity squared. A negative squared is what? Positive. So that becomes negative 5x squared. And then if I take a negative x and plug it in there, I'm going to get 3 times negative x, which is going to give me a negative 3x. And then my last one is this. So when we look at this, we can say, okay, I don't have any sign changes. So this means I have 0 negative rational roots. Okay. Now, where that comes to, what do you mean this positive or negative? If we have my xy axis, positive is over here. Negative is over here. So what this basically means, this will not cross at a rational number. A rational number can be written as a fraction, okay? Or just be a whole number. But it's not going to cross the x-axis in the pink at a rational root. Does that terminology make sense? Okay, again, rational can't be written as a fraction. Okay, but again, I'm blowing up where we would have to go with this. So then that right there was the initial test, the way to shortcut this kind of problem before technology came out. Okay, so then we look at it and we say, okay, so I know this is key, so I'm not going to plug any numbers in. So I'm going to put a 1 out front, and I'm going to take all the factors of 15 over all the factors of 1. So the factors of 15 are positive and negative 1, positive negative 3, positive negative 5, and positive negative 15, all over positive or negative 1. Well, if I have something over 1, it's just going to be a whole number. Then, because we know there's no negatives, I can get rid of all of the negative signs. So theoretically, this graph, as it sits, we can have either 1 or we can have 3 times that it crosses the x-axis at a rational number in the green region on the xy axis. Okay, and this is way beyond. I mean, this is weird theoretical math. And so what you would do with this is once you do that, you then go to synthetic division to make it work. Okay? Now, all of this here became obsolete with the graphing calculator. Okay? AKA Desmos. So with kind of this in mind, let's take a look at what Desmos would say this graph is supposed to look like. And what we're worried about only is where it crosses the x-axis. I'm not worried about where its maximum values are and my minimum values at this point. All right, so let's jump on Desmos, and I have to keep it as y equals. And so I have x raised to the third minus 5x squared plus 3x minus 15. Now, some of you might have been able to look at this and say, I can see that I could have probably done this factor by grouping. And I'm pretending that we don't know what factor by grouping means at this point. Okay? So I see that it's doing this, and I'm just going to zoom out. And this graph shows me an awful lot of information. How many times does this graph appear right now to cross the x-axis? This is the x-axis. Once. Okay? All right, so it crosses here at 5, 0. Okay? Remember originally when I said Descartes' rule of signs, we would have 1 or 3 crossings of the x-axis. Did I satisfy that argument of what I had said? We have 1 crossing, correct? How many solutions does this actually have? What's the highest exponent? 3. So there are 3 solutions to this problem. That doesn't look like a bounce or a wiggle. That's just crossing. So that means that we are guaranteed on this problem to have 1 real rational, that's a double take on words because it's part of the real number system, it's also part of the rational number system, solutions. I am not sure what the other solutions are right now, but I can tell you where this little jump up and down taking place, comes up, goes down, comes up. There's some sort of solution that's going to take place. So let's investigate what that's going to mean. So what you're going to do with these types of problems, I'm going to show you how to work out the rest of this, is you're going to use Desmos first. You're going to see how many times is it going to cross the x-axis. Okay, I can see that 1 time. I guarantee that 1 time. So now I'm going to use something called synthetic division. So I'm going to remember 5, 0. And let's just move on. So I know that 5, 0 per Desmos is a solution. So this means that x is equal to 5, which means x minus 5 is going to be one of the binomials when I factor this out. Okay? So I'm going to use synthetic division. And I want to show you how synthetic division works. My original equation was this. Okay, first thing you want to do when you start doing synthetic division, I am going to look at my exponents first. I go to a power of 3, to a power of 2. This is a power of 1. And we have to be able to recognize that this theoretically could be x raised to the 0 power. A number raised to the 0 power is equal to 1. So you need to know that if you have just x by itself, that's to the first. So am I missing anything sequentially as I count down? I go 3, 2, 1, 0. Am I missing any exponents? No. You following what I'm doing so far? Okay. That's great. I also have to recognize that I have a 1 in front of a variable if there's not a number sitting there. So there's a 1 out front. Okay? What I want to do from this point is I want to say, okay, I'm going to take all of my lead coefficients, including the sign, and I'm going to just write those out. So I have a 1, I have a -5, I have a 3, and I have a -15. And you're kind of spacing them out, but all I'm doing is I just have that. Okay? Ready? Remember what a division sign looked like back in the olden days? It went up and right. Synthetic division, just to mess with society, it's going to be upside down. Okay? What was a guaranteed 0 from this problem? 5. I'm going to put that 5. This 5 is going to come right outside here. And when you do synthetic division, it is honestly done this way. The first number comes straight down. Every time. Not just sometimes. As long as your exponents are in descending order, if they're not in descending order, rearrange it so it's in descending order. And that's the first step. First number comes down. Okay? Whatever that base number is gets multiplied by the outside divisor. So 1 times 5 this week is equal to what? 5. I'm going to add straight down. If I add straight down, -5 added to +5 is? Good so far? 0 times 5 is? 0. If I add 3 to 0, I get? Okay. All right. 3 times 5 is? If I add those together, I get? Okay. This is good. Because this end number is 0, this verifies 5 is a solution. If it's a solution, that means it is crossing the x-axis. If that 0 was any other number, that would just mean that the point 5, whatever that number exists on the graph, but not at the x-axis. So notice I have 5, 0 here. I have 5, 0 here. That's what it means. Okay? All right. Yeah.
So I just put the next one in, and you get 3 solutions. So in that case, why would you like?
Oh, you wouldn't. Okay. All right. Ready? What was my original highest exponent on this problem? 3. When you divide, it means you break something down. Agreed? So that means I'm going to take this 1 and I go 1x squared plus 0x plus 3. So we can clean that up a little bit. This becomes x squared plus 3. So this problem factored down is x minus 5 times x squared plus 3. And that's how we do it. That's kind of heavy. That's what's taking place when synthetic division won't work all the way. Okay? Now, I want you to see something, but you don't have to write it down. I'm going to use pink. Okay? We're going to FOIL this just to verify. X times x to the second power is what? X to the third. -5 times x squared is? -5x squared. X times 3 is? 3x, positive 3x. And -5 times 3 is? My friends, is this the same as this? So it verified. So my answer is parentheses or quantity x minus 5 times the quantity x squared plus 3. So this is my answer. This is the factored version of it. But the key is, if it doesn't cross, if it was raised to the third power, I'm not expecting you to go through and do Descartes' rule of signs. Okay? I just wanted to show you that in order to do something like this, this is what you have to actually do. Okay? But we have Desmos, which means Descartes' rule of signs gets thrown out the window. Sorry, ancient mathematician. We got technology now. Okay? Now, did you say on number 17 you saw 3 places it crossed?
Yeah, and same on number 18.
Same on 18? Cool. All right, so let's take a look at number 17, where it crosses, just to make sure we all feel good about it. So, first thing you do, you look at number 17. You say, okay, it's raised to the third power. That's my highest exponent. So that means I have 3 solutions somehow. It could cross the x-axis 3 times. Okay. Y equals x raised to the third plus 3x squared minus 6x minus 8. Ooh, that's pretty good. Now here is, let's zoom in on this a little bit. Here are my solutions. Okay. Does anyone want to take a shot at what one of the binomials would be? Yeah. X plus 4. Somebody else, tell me what one of the others would be. X plus 1. And the last one? Close. Opposite sign. X minus 2. Yeah. So x plus 4, x plus 1, x minus 2. So this one factors very nicely. Okay? Does that make sense? You understand what we did? And again, we're not trying to make this difficult. We're trying to say, okay, we have this beautiful technology called Desmos now, or you have a graphing calculator, but I think Desmos is a lot user-friendlier because on your screen, you're probably seeing that you can stretch out, do all kinds of things with your graph to make it work, or you can hit the plus minus to make it work. Okay? You said 18 worked the same way?
And so did 19.
And 19 came up with 3 whole numbers? Cool. Okay. So let's go back to one of the homework problems that we had just worked on briefly. Oh, where'd it go? That's what I want. I'm going to go here. I'm going to go here. Not that one. Oops.
Oh, I lied to you about 19. 0.5 is one of the answers.
Oh, so 0.5 is 1/2, right? Yeah. So make sure you go, that becomes 2x minus 1. All right. Will you turn over to the 3rd page that says Algebra Review number 2? Algebra Review number 2. I think you might like this. Okay. So originally in algebra courses, you need everything to be on the same side, set it equal to 0 to start solving it, unless it was just x, right? Do you agree?
Yeah.
Now what we're going to do is take a look at problem number 1. It's x squared minus 3x equals 10. Okay? Still following me? Well, because we have Desmos available to us, let's do it this way. I'm going to do y equals x squared minus 3x, and then I'm going to do a second equation of y equals 10. Notice what I have up there on the board. Okay, I have the left side equal to y, and I have the right side of my equation equal to y. So what do you notice about the picture? We have a straight line and we have a parabola. Okay? We want to solve this problem. Okay, when we solve this problem, we are concerned about the x portion of each of the points where it crosses. I'm concerned with the x portion only. What are my two answers? Done. Okay. Now, on that original problem, I could have subtracted 10 from both sides, getting x squared minus 3x minus 10 equals 0. I could have factored that to become x minus 5 and x plus 2. I could have taken x minus 5 and x plus 2 and set each of those equal to 0 to get the exact same answer. Okay? So let's talk what we should do for next time tomorrow. Oh, hey, what's tomorrow? Friday. What happens every Friday in here? No, it's not quite a wind day. It's close, but it has some application. What do I do every Friday? What did I say? You what? Test? No, better than that.
Real life applications.
Okay. So, meaning that you're my only class. So, let me assign the assignment first. So, I had already assigned you review number 1 through 15. And I'm almost positive every one of you, regardless of being here or not, did it. Agree? So I would like you to finish review number 1. I would like to make sure that 16 through 19 is done. And then I would like you to do on review number 2, I want you to try problems 1, 2, and 3 using Desmos how I just did it. Remember, we're looking for the x value only. And that's where it crosses of the point. Okay? Set each side equal to y. Y equals the left side, y equals the right side. Graph the two and see what happens. Okay? Now, here's the important thing. We have real life math tomorrow. Okay? I'm going to give you 3 different topics. We will eventually talk about all 3 of these topics in some order. So, would you like estate division? Would you like rent to own? Or would you like health savings account? Okay. So you will see all 3 of these within the next couple of weeks. I just don't know which order you would like to be in. Okay? Let me explain what each one is first. Estate division is I do a scenario using the cartoon Scooby-Doo to talk about the characters of Scooby-Doo inherit a mansion, $1 million, a lifetime supply of Scooby Snacks, and the Mystery Machine. And how would it be divided fairly amongst 5 people? Because we're counting Scooby-Doo as we don't count Scrappy. I'm sorry, Scrappy ruined Scooby-Doo for me. But Scooby-Doo is counted as a real person. Okay, rent to own is it a good idea for you to go to a rent to own and purchase your furniture where you pay for it week to week? HSA is a health savings account, which is a triple tax protected feature of math. So, by a show of hands, who wants estate division tomorrow? Boy, I hope somebody's voting for somebody. Who wants rent to own? I got 1, I got 2, I got 3, 4, 5, 6. 6 of those. Who wants health savings account? 1, 1, 2, 3, 4, 5, 6, 7, 8. All right, health savings account it is tomorrow. Cool. Cool. All right, you guys know what to work on. Those of you that just got here first day, please realize I record my lessons and I post them on Schoology. You are always welcome to refer back to that.